Hello physics students, welcome to my short video tutorial on Archimedes principle. This is an excerpt of my YouTube upload on solving a problem on the law of buoyancy. So stick around, watch and learn. Question number 4. A large plastic cylinder with mass 30.0 kg and density 370 kg per meter cube is in the water of a lake. A light vertical cable runs between the bottom of the cylinder and bottom of the lake and holds the cylinder so that 30.0% of its volume is above the surface of the water. What is the tension in the cable? As shown in our sketch, we have here the cylinder that is attached to a cable. Okay, the cable is holding the cylinder or preventing the cylinder from moving or floating, okay, on the surface of the water. Because if you notice, this cylinder, plastic cylinder, is less dense compared to water. Its density is only 370 kilogram per meter cube. Okay, so that is less than the density of water. So we expect this cylinder to float in the water. All right. But in this situation, 30% of its volume is above the surface because it is being held by a cable that is attached to the bottom of the lake. All right. In other words, there is a force exerted on the cylinder coming from the cable. We call it the tension force. The tension force is directed downward because it is preventing the cylinder from moving to the surface. So, you notice there are two forces acting on the cylinder and both forces are directed downward. The tension force of the cable and the force of gravity, mg, which is the weight of this cylinder. The only upward force is the force, buoyant force, exerted by the water on the cylinder. And it is understood that the cylinder is at rest, so it is in static equilibrium. All right? So our analysis for the forces acting on the cylinder is such that the upward force must be equal to the two downward forces. So later on, we're going to calculate for that value of the tension force. But first, we have to determine uh, the volume of the cylinder given its mass and its density. See, we just divide the mass, which is 30.0 kilogram, by the density of the cylinder, 370 kilogram per meter cube, and we get 0.081 meter cube. This is the density, the volume, total volume of the cylinder. Okay, 30% of that volume is exposed or above the surface. That means 70% of the total volume of the cylinder is submerged in the water. So we calculate for that by simply multiplying 0.7 by 0.081 meter cube, and we get the volume of the cylinder that is submerged in the water, 0.057 meter cube. Okay, because this volume also represents the volume of water that is displaced by the solid cylinder. Okay, we need that so that we can determine the force, buoyant force FB exerted by water on the cylinder using the formula FB equals density of water multiplied by Vg, where V is the amount of water that has been displaced. Alright, so substituting, we get density of water, as we all know, is 1000 kilogram per meter cube, or 1.0 raised to the third power. Multiply that by V, which is the amount of water submerged, the amount of volume of the solid cylinder that is submerged in water, or the amount of water that has been displaced. So 0.057 multiply also by 9.8 meter per second squared, and we get this buoyant force equal to 559 newtons. All right. And lastly, we now get the amount of the tension force in our diagram. The tension force T can be isolated, so we will have the equation T is equal to the upward force Fb minus the force of gravity mg. All right? And substituting the force of buoyant force, earlier determined as 559 newtons, minus the product of the mass, the cylinder, which is 30.0 kilogram, multiplied by 9.8 meter per second squared. So we will get as the value for the tension force equals 265 newtons. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.